Hello again. How are those Rube Goldberg machines coming? Make sure you keep working on them. Even if we finish the chapter, this is really the last chapter that we're going to do for this entire year. So our Rube Goldberg machines are not going to be due in their finality until June. That means that if you feel like you have yours finished and you hand them in now, I'm not going to accept them because you have a whole bunch of time to perfect it and make it better and bigger and huge and amazing. So keep working on them. All right, we're still talking about simple machines. We talked about how they helped us yesterday, how they multiply the force that you're adding, that they can change the direction you're putting force in, and that they can multiply the speed. Well, we have a couple other words we're going to throw in, and this word we already know. We already know the word effort. That effort is the force applied to do work. But sometimes when you see a diagram, it might just have the letter E there, and it's standing for effort. And in the picture that we're seeing, this girl's trying to lift a rock, and in the rock is the load or the resistance, and the effort is where she's pushing down. Remember, the effort is a force, a push or a pull, that causes a change in motion. And I already used this word, but here's the definition. The load is always labeled R. It's the resistance. It's the thing that you're trying to lift or trying to overcome. So again, now we have a guy using a lever, and he is putting his effort down on one end, and the load that he's trying to lift is over on the other end. Now, looking at this thing, I love this picture because as soon as he finishes pushing where he is, he's going to flip that load all the way off the edge of the dock. So I'm not sure that's what he wanted to do. But anyway, the load is the resistance. Now here's where we're going to spend a lot of time, and that's mechanical advantage. Why do we need these machines? Well, if you remember, I said that I could move a walrus, but I could move a car at the same amount of weight. When I use a machine, it increases the amount of effort that I'm able to add. So if you look on the left-hand side, there's poor little ant sitting on one side of a seesaw and the elephant sitting on the other side of the seesaw. Kind of a weird picture because the elephant should be down on the bottom. The ant should be way up at the top because the elephant's so big. Well, the cats, on the other hand, have solved the problem. They have a really heavy cat, and by adding more light cats to the other end, they're able to lift even a heavy weight. So it makes me wonder what the ant has added. Actually, I know it has to do with a triangle underneath, but that's another story. So the thing that we're going to look at, the first type of simple machine that we're going to look at is an inclined plane. An inclined plane is basically nothing more than a stick, kind of a stick. I shouldn't say it's a stick. It is a plane, a board, if you will. An inclined plane is a simple machine with no moving parts. It's simply a straight, slanted surface. There's a picture of it. Doesn't look too exciting. Pretty simple, in fact. But it's really helpful. Take a look at these pictures. Look at the picture of the girl on the slide. She wants to get from the top of the slide all the way down to the bottom. She wants to get from that height down to the ground. Which would require have worse results? Her jumping off the top of the slide and landing on the ground, or sliding down the slide? How about the guys that are lifting the piano? They're not really lifting it, they're rolling it up a ramp. It's still taking 3 of them to do it, but do you think 3 of them could actually lift the piano up into the truck? Or the guy moving the boxes? He could, yes, if they were light, but what if they were really, really heavy? What if they are filled with cans of paint? Could he lift both boxes from the ground up into the truck? Maybe, maybe not. But with a ramp, he can, and that's what an inclined plane is. That's the That's it. It's a straight, slanted board. But did you know, if you take a bolt and you take an inclined plane and you wrap it around the bolt, it kind of looks like something different, doesn't it? Looks like a screw. And that's exactly what a screw is. A screw not only has extra knobs and such so that it holds the wood better, but it also, once it gets in, it takes a long time to screw a screw in, but once it gets in there, it holds the material so much better than a simple bolt or a simple nail. It is an inclined plane wrapped around a pole. So we mentioned mechanical advantage, the number of times the machine multiplies your effort. So how can we figure out how much using an inclined plane is going to multiply the amount of effort that we use? Well, we have a definition, and we need to understand two parts of the inclined plane. The mechanical advantage for it is the length of the slope divided by the height. So if we were ever to try and figure out the mechanical advantage of a plane, of an inclined plane, we would measure how long the slope is, how long the part is that we are going up on. And then we would measure how tall the plane is. So if it's leaning against a truck, how high is the truck? We would multiply the length of the slope, shut my mouth. We would divide the length of the slope by the height. And the answer that we get is the mechanical advantage. So if we got the mechanical advantage of 3, it would mean that by using that machine, which is the inclined plane, we were doing the work that otherwise would have taken 3 of us to do elsewhere. That's what the mechanical advantage is. It tells us how much more our effort is multiplied. So the higher that number is, the higher the mechanical advantage is. So here's an example. Here's a board. Its length is 20 feet and its height is 4. Boy, I can't talk today. So what is the mechanical advantage of using this? A ramp that's 20 feet long, going up a cement block, taking cement blocks and pulling them up onto a porch. Now, you and I could probably take one cement block at a time and lift it up onto the porch. But what if we could lift all the cement blocks at the same time? And we used a ramp, we used an inclined plane. What would be the mechanical advantage? Well, 20 divided by 4 is 5. So by using that ramp, we're doing what 5 of us, if there were 5 of us, could have done by lifting. Mechanical advantage. And notice how I labeled my mechanical advantage, 5MA. That's the label it should have. Well, why does this work? We're just going to simply say right now that it spreads the work out over a bigger distance. And by spreading the work out over a bigger distance, it allows the effort to be smaller. When we get into talking about pulleys, we'll really explore this idea even further as to why this works. Well, another one that can be considered a inclined plane, but also is a simple machine or simple tool, is a wedge. And one of the things that a wedge does, remember what simple machines do? They can change the direction of your force. So one of the things, if you've ever chopped wood, if you use a wedge and a sledgehammer, and you smash down on the top of that wedge, the wedge not only goes and puts the force straight down, it also pushes the force to the sides. And when it does that, it helps to separate that wood even further. Now I'm going to stop. I know it's a little short today, but I'm going to stop today because I have a homework assignment for you to do that is on inclined planes, and I don't believe any of you have it if you picked up papers at school. It's one that you will be writing on. Well, no, let me take that back. You're not going to be writing on it. You can take it right down from Google Docs. You'll be writing your answer on it. You notice that on it, it tells you to write your answer with to the nearest tenth. And so when you do your division, you can use a calculator if you like. Do it to the nearest tenth. If there's anything to draw on it, you could always draw on a separate piece of paper and then send a picture to me. Just take a picture of that. But keep working on your Rube Goldberg and keep watching the Rube Goldberg videos, and I'll talk to you later.